All right, we now have our final speaker for this session before we open up the floor for questions and discussion. And Gowthami Venkateswaran will be presenting the domino effect, impact of fast food chains on urban health in India.
Hello, everyone. I know this is the last session, so I'll be quick. You all can leave. So my topic is Domino's effect, impact of fast food chains on urban health in India. But I think it really should be how fast is my heart pounding right now. So we're just looking at the impact of your health depending on how many restaurants you have around you. I want to give you a quick overview of what the next 10 minutes is going to be. So the research question is simple. What is the impact of access to unhealthy food on urban health in developing countries like India? And for the data, we use the DHS data, which is the ANH's version 4. And we also use spatial data for the restaurant density, which is from Google Maps. So we have around 200,000 data points. We're also using nightlight data as a proxy for economic activity. And we are looking at health outcomes such as BMI, blood pressure, and glucose levels. And what are the results? So we find significant impact of higher restaurant density on health outcomes, especially with the BMI. So going on. So our research is motivated by the need to understand the double burden of malnutrition in developing countries. So we know that India has a lot of children who are malnourished, but India also ranks third in the world in the number of obese people and second in the world for the type 2 diabetes. So there's a lot of studies addressing the malnutrition in rural areas. So we want to look at malnutrition in urban areas. And the government is also considering policy options like sin tax, otherwise called fat tax or sugar tax. So they just want to tax unhealthy food. One state, the southern state, Kerala, has already implemented such fat tax, which imposes 14.5% tax on all food products that are high in fat and calories in 2016. And another state called Gujarat is also trying to implement this fat tax. So one difficult thing to get rid of all these fast food chains is because they have high foreign direct investments, and the current food sector, the fast food sector, is valued at 57 billion USD. One more point for motivation is that we need evidence to come forward with any kind of policies. And of course, large fast food chains vehemently deny any correlation between obesity and the kind of foods these restaurants serve. So McDonald's has said, we are not the cause of obesity. Ronald McDonald is not a bad guy. He's a clown. He's fun. I'd ask you all to let your kids have some fun too. And they also say we have great side salads. They don't represent a lot of our sales, but we have great side salads. Fun fact, I did not know McDonald's had salads until I made this presentation. I don't know if it's just me. And there's more. In 2004, someone said, there's nobody at McDonald's shoving fries in your mouth. Ooh. So looking at the data, like I said, we use the ANH's data on individuals in urban areas, which is around 0.2 million. And from this data, we have the outcome variables, BMI, blood pressure, and blood glucose. And there are cluster level geocodes for all the households. So we have around 900 clusters that are geocoded. So we could find the restaurants around these clusters. And there are other individual characteristics like the socio-economic characteristics such as the wealth, smoking, or alcohol consumption, education, and other such variables. And for the restaurant density, we actually scraped it out of Google Maps. So I told you that I had 9,000 data points and for the cluster levels. And we retrieved the number of restaurants around each of these clusters. And we also filtered these restaurants with and without serving fast food tags. Like I said previously, we use the nightlight's luminosity and satellite data on climate variables. So we use the climate variables because there are studies that show correlation between high temperature and like unhealthy eating habits. So we want to make sure that we use those variables as well. And for the methodology, we use a basic OLS specification, and the outcomes were BMI, BP, glucose on cluster level restaurant density. And we control for households, individuals, and other cluster level characteristics. We have age fixed effects, education fixed effects, district fixed effects, and like I said, climate, economic activity. So the specification compares the difference in outcome. We do the individuals with the same, like basically everything same except for the number of restaurants around you. But there might be a potential problem, which is endogeneity or self-selection. The restaurants might go closer to areas where people eat unhealthy food. So to address this issue, we use an instrumental variable. And so we currently use the lagged nightlight luminosity and population density to instrument for the restaurant density. I'll talk about the next steps later. So this is to give you a pictorial representation of a quick correlation between obesity prevalence and the restaurant density. If you see, the blue map shows clusters that have an average BMI beyond 25. So beyond 25 is overweight or obese category, mostly like unhealthy population. And you can see the red map shows the points where there are more than 60 restaurants in the cluster. And you can clearly see some correlation in some portions of the southernmost portion and somewhere in the north as well. So these are my results. I just wanted to keep my tables short, so I didn't want to bore you. So I only have the restaurant density variable, and you can see that they're significant. So that one's my OLS as well as the IV specification. So put in perspective, this translates to nearly 0.5% increase at the sample mean density per cluster, which means like you're likely to increase your BMI by 0.5% if you live closer to an area where there are a lot of restaurants. We also find a slight increase in the likelihood of blood pressure, which is on the other side, but the magnitude is fairly small. We did not find a significant effect on the blood glucose level, so I haven't added those results here. So we're looking at it with women versus men, and much of the impact is driven by the effect that we observe is among the women. So for the women, it's like 0.6% increase in the BMI if you live closer to restaurants with high density restaurants. And for men, it's not even significant. So yeah, one more interesting fact is that, so our hypothesis is based on the fact that people eat out a lot if they have more restaurants around them. So the DHS data had this variable, these two variables called fried foods and aerated drinks, where they asked the people how frequently they consumed fried foods or aerated drinks. And they had to rank it between never, occasionally, weekly, and daily. And we ran it against the restaurant density, and we still find it is consistent with the previous results. We find evidence of the potential underlying mechanisms. So we see that the proximity to restaurants results in a higher likelihood of consuming fried foods and aerated drinks. And we see this dietary effects only among women, and it's not significant for men. So with the results, we suggest that the proximity to restaurants leads to unhealthy dietary practices and adverse health outcomes. So our study underlines the need for exploring more policies such as zoning laws, particularly where the population is more vulnerable, like hospitals or schools, and So the next steps would be using, so we think the IB could be made more strong. So we're going to use data from economic census. So they have details about all the enterprises that is registered. And going further, we also want to look at what impacts the sin tax has on the state that has already implemented it. So further research is needed to evaluate the effectiveness of policies like this.